Now, we're not going to add any more points, but we are going to add one more line. It'll be the last one, okay? I want to form a triangle here. I know we've got a lot of points on here. I want to draw an A, B. That's the hypotenuse here, okay? So. Okay. Now, last midpoint. Third and last, lucky last, okay? Where's it going to be? I estimate it'll be about here. Okay, what shall I call it? M, capital M?
Little M.
Big M, midpoint. And because the midpoint of A and B, I'm going to call it midpoint AB, like so. Okay? Now, to work out its coordinates, this is interesting because we've actually done all the work already. We actually have. Can you see why?
3 square.
We can do Pythagoras if we want to work out distances, but we don't need to worry about the distance here. Yes, Appear.
It's like in line with the midpoint of B, P, and...
Very good, very good. Let's show that actually. I'll say it again in case anyone didn't catch it. This new midpoint, the last one, right? It's lined up. It's in line with the other two midpoints we just worked out, right? So maybe you want to do this as well. Put a dotted line across like so. Okay, can you see that? And one more dotted line like this. Okay, so that means its x coordinate. Now where are we going to get its x coordinate from?
From the middle of A and B.
Yeah, very good. The x coordinate of this will be the same as the x coordinate of this because they're on this same vertical line, right? It's directly above. So it'll be 4, right? What about the y coordinate? It'll be 3, the same as this guy. Because everything on this horizontal line will have that same y coordinate. So it's 4, 3. Okay? So, what have we done? We worked out these kinds of midpoints, right? And they gave us the midpoint of this, gave us the x and y coordinates, okay? But we don't want to have to draw a diagram like this and go through all these different points every single time. We want to boil it down to something nice and simple. Something like one of these, a formula, right? So this is our last one, by the way, midpoint. It's going to be equal to, now, let's have a think about this, right? A distance is just it's a length, right? It's just a number, like 5 units or 23 units or something like that. So you end up with a number. Gradient's also a number. So when you stick in all of these x's and y's, you just get a number out. But a midpoint has coordinates, right? So therefore, we should have coordinates in here, some kind of coordinates, right? So I just want to work out what they are. Now, see these things here, right? This is how we worked out the midpoints of here and here. That's how we did those values, okay? So I'm going to bring that approach over here to the formula, okay? The first one you worked out was the average or the midpoint of the x's, right? 4, here, right? So what are these two numbers again? 7 and 1? What's the significance of those?
The x coordinates from A and B.
Very good. The x coordinates of A and P. Also, the x coordinates of A and B, right? So therefore, I want to say, look, take those x coordinates, right? Just like all these previous times, we'll just call them x1 and x2. Those are the x coordinates. You add them up, and then what do? We divided, right? We took the average between them. There you go. So how do you get the x coordinate of the midpoint? Well, you add up those two x values, you divide by 2. What about the y coordinate? How do we get that? In exactly the same way, but for y's instead of x's. y1 plus y2 divided by 2. And that, my friends, is the midpoint formula. That's it. It's simple. In some ways, it's the easiest of all of them because we get like halfway. That's a really easy visual thing to see. Whereas gradient's a bit funny, and distance is it's quite complicated because of Pythagoras. But midpoint, I think we've nailed it. So well done.